Every single day, we open a browser, type a website like google.com and press enter. Within a fraction of a second, the webpage appears. We do this so often that we barely stop to think about it. But have you ever wondered what actually happens after you press that enter key? Hello everyone, I am Sanjana and welcome to Systems Explained, where we break down complex computer science concepts into simple, intuitive explanations. In this video, we're going to follow that single request from your computer all the way to Google servers and back again. Now, let's do something that's impossible in real life. Let's freeze time. Imagine we've paused everything at the exact moment you press enter. As you can see, the timer says 0 milliseconds. At this exact instant, Google hasn't received your request. No data has been sent. Now we arrive at the very first challenge. Take a look at the left side of the screen. Your computer knows that you typed google.com. But if we look at the right side, Google's server is somewhere on the internet. The problem is your computer has no idea where that server actually is. It knows the name, but it does not know the location. Imagine if I told you to deliver a letter to John. You know the person's name, but without an address, where would you send it? Computers face the same exact problem. So the next question is, how does your computer find Google's address? So if names aren't enough, what does a computer actually need? Take a look at the left side. As humans, we use names like google.com because they're easier to remember. But if you look at the right side, computers don't use names at all. They communicate using numerical addresses called IP addresses. You can think of an IP address as the internet equivalent of a home address. Just like a courier needs your house address to deliver a package, your computer needs Google's IP address to deliver its request. But here's the interesting part. How does your computer find Google's IP address in the first place? So now we know that the computers need an IP address instead of a website name. But where does that IP address come from? Let's start from the left. Your computer asks a simple question. Where is google.com? It sends that question to DNS, which you can think of as Internet's phone book. DNS looks up at the address associated with google.com and sends the corresponding IP address back to your computer. Now, your computer finally knows where Google's server is. And with the destination found, the real journey can finally begin. By the way, the full form of DNS is Domain Name System. Now that your computer knows Google's address, it's finally ready to send the request. If you follow the flow on the screen, the request starts from your computer, enters the internet, and begins its journey to Google's server. But here's something more interesting. It doesn't travel as one huge message. In fact, if it did, sending data across the internet would be much less efficient. So the question is, how does the internet actually send your request? At first, you might think your computer sends one large request across the internet, but that's not how it works. Instead, your request is broken down into many smaller pieces called packets. You can see that happening here. One request becomes packet 1, packet 2, packet 3 and packet 4. Why go through all this trouble? Because smaller packets are much easier to send, route through the network and put back together at the destination. But now we have another interesting question. If these packets are all traveling separately, how do they know where to go? So now our request has been split into multiple packets. But how do these packets actually reach Google's server? Let's follow the same path on the screen. Every packet starts from your computer and instead of traveling directly to Google, it passes through several devices called routers. You can think of these routers as traffic managers for the internet. At each router, the packet is forwarded one step closer to its destination. This process continues until every packet finally reaches Google's server. But here's another challenge. What happens if one of those packets never arrive? Let's imagine something goes wrong. As you can see in step 1, your computer sends 4 packets, P1, P2, P3 and P4 respectively. Now move to step 2. Notice that packet 3 never reaches its destination. It gets lost somewhere along the way. Without that missing packet, Google receives an incomplete request. So what happens next? That's where TCP comes in. TCP, also known as Transmission Control Protocol. In step 3, TCP realizes that packet 3 is missing and asks for one packet that has to be sent again. Finally, in step 4, only the missing packet arrives. All 4 packets are put back together in the correct order. This is what makes the internet communication reliable. But now there's one final question before our request reaches Google. Even if all the packets arrive safely, can someone else read them while they're traveling across the internet? So far, we've made sure our request reaches Google completely. But there's one more important question. What if someone intercepts that request while it's traveling across the internet? Take a look at the left side. If your request was sent as plain text, anyone who intercepted it could read exactly what was inside. That's clearly not something we'd want. Now look at the right side. Before your request leaves your computer, HTTPS encrypts it, turning it into a format that looks very random and it's actually unreadable data. Even if someone manages to intercept it, they can't understand what it says without a proper key. That's why whenever you see the little padlock icon in your browser, it's a sign that your connection is secure. Now our request is complete. It's reliable, it's secure. So what happens when it finally reaches Google's server? After traveling across the internet, our request finally reaches one of the Google server. If you look at the left side, you can see that all the packets have successfully arrived and are reassembled into a single request. Now that servers read that request, in this case, it's a simple GET request, which is just your browser's way of saying, I'd like to see Google's homepage, please. The server understands exactly what you're asking for, and now it has one job left. It needs to prepare a response and send it all the way back to your computer. Now that Google understands what you've asked for, it starts preparing the response. If you look at the left side, the server creates a response package that will be sent back to your computer. But what exactly is in that package? It contains everything your browser needs to build up the web page you see on your screen. Things like HTML for structures, CSS for design, and JavaScript for interactivity. Just like before, this response isn't sent as one large file. It is broken into smaller packets and begins its journey back across the internet. But now another question comes up. How does that response find its way back to the computer? Google has prepared the response. Now it's time to send it back to your computer. If you follow the flow on the screen, the response leaves Google's server, is broken into data packets, travels through internet routes, and finally reaches your computer. Just like the original request, the response follows the same journey back, only in the opposite direction. And once every packet arrives successfully, your computer has everything it needs. But one final question remains. What does your browser do with all this information? After traveling all the way across the internet, the response finally reaches your computer. But your browser still has one more job to do. Take a look at the left side. A few moments ago, all we had was a blank browser window. Now the browser reads the response it has received, understands the HTML, CSS and JavaScript and puts everything together into the web page. And just like that, Google's homepage appears on your screen. The amazing part is that this entire journey from pressing enter to seeing the web page usually happens in just a fraction of a second. Now, let's put everything we've learned together. Let's take one final look at everything we've just covered. It all started when we typed google.com into the browser. DNS helped us find Google's IP address. With the destination known, our request was broken into packets and sent across the internet through routers. TCP made sure every packet arrived successfully, while HTTPS kept the communication secure. The request reached Google's server, which prepared a response back and sent it back. Finally, our browser took that response and displayed the Google's homepage on our screen. And the amazing part is all of this happened in just less than a second. So if this entire journey happened from just one press of the enter key, what computer science concepts were working behind the scenes? We've just spent the last few minutes following a single search request across the internet. But if you look at this table, you'll notice something interesting. Every step in that journey was powered by a different computer science concept. DNS found the destination, the IP address identified where to go, packets made the data easier to send, routers guided those packets across the internet, TCP made sure nothing was lost, HTTPS kept everything secure. The server processed the request, and finally, the browser turned all the data into the web page you can see on your screen. None of these concepts work alone. They work together like parts of one giant system. And that's really the biggest lesson from today's video. Computer science isn't about memorizing individual concepts. It's about understanding how those concepts connect to solve real-world problems. It all started with something we have done thousands of times, right? But behind that one simple action, your computer found an address, communicated across internet, reached servers that may be thousands of kilometers away, received a response, built an entire web page, and in less than a second, oh my god, the next time you search for something online, you'll know that there's an incredible journey happening behind the scenes. And this is exactly what Systems Explained is all about. Understanding the invisible systems that power the technologies we use every single day. If you enjoyed this video, consider subscribing. I'll see you in the next one. Thank you.